Hi there. So I looked over those questions that you were wondering about, and I thought we could just walk through them here together on this video. So this is the first one, problem number one. So I just wrote it down. So the first thing that you're going to want to do is separate this out a little bit. So this whole entire fraction here is raised to the 3/11th power. So what we're first going to do is separate the numerator and the denominator. So I'm just going to go like this. I'm going to do the 4 to the 1/3 times 4 to the 2/6 and raise that to the 3/11th power. And then separate that from the denominator, 4 to the 5/6 to the 3/11th power. So all I did was separate the exponent and put it one in the numerator, one in the denominator. Okay, so next what I'm going to do is just work on the numerator for a minute. We know that when we have something in parentheses raised to the power, that means that this power is going to go to both of those things inside the exponents. So I'm going to separate those a little bit. So I'm going to have 4 to the 1/3 raised to the 3/11th power times 4 to the 2/6 raised to the 3/11th power. So I separated the numerator. And I'm just going to leave the denominator as is for this step. So now I can start simplifying these individual exponent problems. If you just think of them each individually, it's a little bit easier. So right here, I have 4 to the 1/3 raised to the 3/11th. So I'm going to use the power raised to a power property, and I'm going to multiply these two fractions. So that gives me 4. And if I multiply the numerators here, I get a numerator of 3 and a denominator of 33. I'm going to do the same thing over here. I have a power raised to a power, so I'm going to multiply those two powers together. So I get 4 to the 6th over 66. And on the denominator, I'm going to do the same thing. I have a power raised to a power, so I'm going to multiply the two powers together. So I end up with 4 to the 15 over 66. So I have these a little bit more simplified now. For me, I would probably choose to add these next. So when you have two numbers that are the same base, both raised to exponents, remember you can add those exponents together. So the problem is that with fractions, you have to have a common denominator to add. And right now we don't have a common denominator. So I'm going to change this 3 over 33. I'm going to get that to be a common denominator with 66. So if I change the 33 to a 66, I multiplied the denominator by 2. So I'm going to multiply the numerator by 2 also. So I have 4 to the 666 times 4 to the 666. So if I just add those exponents, that gives me 4 to the 1266 on the top of that fraction. And then on the bottom, I have 4 to the 15 over 66. So now we have that quotient property of exponents. When we have the same base on top and bottom, we can just subtract the exponents. So I have to do 12/66 minus 15/66. So when I do that, I get 4 to the negative 3/66. And so I'm simplified pretty well right there. Now you just have to decide how you want to format it. Since this is a negative exponent, that means that technically this 4 should be in the denominator of a fraction. So it should look more like this: 1 over 4 to the 3/66. That up. So this is what my answer looks like right here. And you can simplify this 3/66 fraction if you want. But if you look over at the answer choices for this problem, they actually left it as 3 over 66. So you have to decide which of those 4 answers is the same as this. So you can play around with this fraction a little bit. You know, this is the same thing as saying 1/4 to the 3/66. So if you find that answer over there, that's great. The reason some of those other answers don't work is the first answer they had as 1/4 to the negative 3/66. So you can either write it as 4 to the negative 3 over 66, or you have to change it to the fraction form to make that exponent positive. So that is problem number 1 there. And let's go to problem number 2, or I guess you were asking about problem number 3. So the problem number 3 on that workbook looked like this. It had a big square root of 5 to the 1/2 power times 4. And that was the numerator. In the denominator, it was 2 times 5 to the 1/3 power. So again, we're going to just kind of take it step by step and simplify it as much as we can. So just looking at the numerator, we're going to want to separate that square root out a little bit. So I'm going to make it the square root of 5 to the 1/2 power, and then the square root of 4. So I just broke up that square root to each of the things that were under the square root. Now, and I'm just going to leave the denominator the same for right now. So now for the top, that square root of 5 to the 1/2 power. We know that a square root is the same as a 1/2 exponent. So this is the same as 5 to the 1/2 to the 1/2 power. So all I did from here to here is I just changed it from writing square root. I wrote to the 1/2 power instead. Those are the same thing, a square root and a 1/2 exponent. So simplify it like that. This one, the square root of 4, the square root of 4 is 2. It's like an actual number, so I'm just going to write 2. And I'm just going to leave the denominator as is for this step, since I was just working on the numerator. Now, if you remember back about how to simplify fractions or things like this in general, since we have a 2 on the top and the bottom, we can cancel those out. 2 divided by 2 is just equal to 1. So we can cancel out these 2's and get them out of our problem. That's a little bit helpful. And now I can tackle this guy right here, 5 to the 1/2 power raised to the 1/2 power. Since we're raising a power to a power, we are going to multiply those exponents together. So that becomes 5 to the 1/4 power when I multiply 1/2 times 1/2. And on the bottom of my fraction, I still have this 5 to the 1/3 power. So now we're going to use the quotient rule. Because we have the same base, they're both 5, we can subtract these exponents. So what I really need here is 5 to the 1/4 minus 1/3. Now, when you're subtracting fractions, we need a common denominator here. So I'm going to make those denominators 12. So 1/4 is the same as 3/12. 1/3 is the same as 4/12. So I got a common denominator so that I can actually subtract those fractions. So 3/12 minus 4/12 is negative 1/12. So this is my answer. Now, again, you can leave it like this, or you can turn it into a fraction so that that negative exponent will become positive. So this is the same as 1/5, or 1/5 to the 1/12. You could also write that like this, 1/5 to the 1/12. So there's lots of different ways to write this, and that's why there's a lot of answers over on the other side that you'll have to figure out which of those answers that they gave are the same as these. And sometimes that can be a little bit tricky. So just take the first example answer. So these are the answers that I got. That doesn't mean that they're only answers. You can write this in a lot of different ways. So the first answer that they give you over there, like choice A in the multiple choice, is the 12th root of 5 to the negative 1. So let me just show you the process of how I decide, is this the same as one of these? So I know that the 12th root is the same as writing, I'm just going to keep this 5 to the negative 1 the same. Instead of writing the 12th root, I could raise this to the 1/12 power. Those are the same thing. The 1/12 power is the same as the 12th root. So now if I'm raising a power to a power, I know I can multiply those two things together. So negative 1 times 1/12 is negative 1/12. So this answer is 5 to the negative 1/12. And I had one of my answers over here was 5 to the negative 1/12. So I would say, oh yes, choice A is one of the correct answers in that list. Now make sure you saw that this was select all that apply. So you're going to have to go through a similar process like this with choices B, C, D, E, all of the choices, and decide if it's the same as the answer that you got. So hopefully that helps you. Let me know if you have any other questions on those problems.